Planet LHS3844B may have volcanoes lighting up the night sky. Until recently, researchers found no evidence of global tectonic activity on planets outside of our solar system. However, under the leadership of a research team from the University of Bern and the National Center of Competence in Research Exoplanets, astronomers and scientists have now found that the material inside planet LHS3844B flows from one hemisphere to the other and could be responsible for numerous volcanic eruptions on one side of the planet. On Earth, plate tectonics is not only responsible for the rise of mountains and earthquakes, it is also an essential part of the cycle that brings material from the planet's interior to the surface and to the atmosphere, which is then transported back beneath the Earth's crust. Tectonics thus has a vital influence on the conditions that ultimately make Earth quite habitable. Previously, however, researchers had found no evidence of global tectonic activity on exoplanets. The research team would have worked towards this mission, and they found evidence of the flow patterns inside a planet, which is located 45 light years from Earth. This planet is LHS3844B. Their results were recently published. An extreme contrast and no atmosphere is what they observed. Observing signs of tectonic activity is very difficult because they are usually hidden beneath an atmosphere. However, recent results suggested that LHS3844B probably does not have an atmosphere. It is slightly larger than Earth and, likely similarly, is a rocky planet. It orbits around its star so closely that one side of the planet is in constant daylight and the other side is in permanent night, just like the same side of the moon always facing the Earth, with no atmosphere shielding it from the intense radiation. The surface gets blistering hot. It can reach up to 800 degrees Celsius on the day side. For the night side, on the other hand, it is quite cold. Temperatures there might fall below minus 250 degrees Celsius. The researchers thought that this severe temperature contrast might affect material flow in the planet's interior. To test their theory, the team ran computer simulations with different strengths of material and internal heating sources, such as heat from the planet's core and the decay of radioactive elements. The computer simulations included the large temperature contrast on the surface imposed by the host star. They looked at the flow inside of the planet from one hemisphere to the other. Most computer simulations indicated that there was only upwards flow on one side of the planet and downwards flow on the other. Material therefore flowed from one hemisphere to the next. The team observed that based on what they are used to from Earth, they were expecting the material on the hot side to be lighter and therefore flow upwards and vice versa. However, some of the team's simulations also indicated that the opposite flow in direction was possible. This initially was counterintuitive in terms of a result, and this was due to the change in viscosity with temperature. Cold material is stiffer and therefore doesn't want to bend, break, or subduct into the interior. Warm material, however, is less viscous, so even solid rock becomes more mobile when heated and can readily flow towards the planet's interior. According to another individual who was a part of the research team, either way, these results indicate how a planetary surface and interior can exchange material under conditions very different from those on our Earth. In looking at the volcanic hemisphere, they said that such material flow could have bizarre consequences. On whichever side of the planet the material flows upwards, one would expect a large amount of volcanism on that particular side. They also pointed out that similar deep upwelling flows on Earth drive volcanic activity at Hawaii and Iceland. One could therefore imagine a hemisphere with countless volcanoes, a volcanic hemisphere and one that is almost non-existent in terms of an atmosphere. Their simulations show how such patterns could manifest, but it would require more detailed observations to verify same. With a higher resolution map of surface temperature, they could be able to point to enhanced outgassing from volcanism or further detect volcanic gases. This is something that they hope to spend time doing future research on, and this they hope will assist them in understanding what is currently occurring on planet LHS3844B. Like, comment, share, and subscribe. Thanks for watching. Goodbye.